Hello everyone, welcome back to my channel again. Today I'm going to show you problem solving, like how to elucidate the structure from your IR, NMR, uh, carbon NMR and proton NMR and other information given. So here is the problem one. The informations are given here like a couple of spectra. You will slowly know like the top one is IR, and there is a UV and a mass spectroscopy, and also the carbon NMR, both proton decoupled and proton coupled carbon NMR. And at the end you will see the proton NMR, how it looks like and what are the critical information you have to pick up from those spectra. I will explain details from this problem solve. So here so very first, you have to look for the chemical formula. So from where you can calculate the soda number. Here is the chemical formula. So you know the calculation of soda from my previous video. So I'm not going to more details on it. But so I know the you remember x plus 1 minus y by 2 even if you have the oxygen in this molecule. So here the x is the 4, carbon number 4, plus 1 minus y is the number of proton, so 8 over 2. So you have 5 minus 4 equal to 1. So you have soda number 1. That means primary information, you have a double bond, a ring in the structure or in the molecule. So so in the mass spectroscopy, it is showing the molecular mass is 72. So you can count like how many carbon you have, 4, and carbon mass is 12, plus hydrogen is 8 times 1 plus 16. So if you sum up all those, and you will get it 72. So mass is correct. And UV is showing, although nowadays people doesn't use the UV a lot, but still it is a kind of information is giving. So UV here like 300 to 250 to 300 nanometer lambda. So this is normally N to pi star transition indicating. So that means you might have the carbonyl group. Although many of the people may not know immediately if they don't have good enough experience on UV and their transition. So, but it is not really important in many cases. Okay, so but IR is the really important. So in IR, if you see here, you see a peak around 1718. Okay, that means carbonyl group. So you have a carbonyl group, and as I mentioned in my IR NMR, also the soda NMR, if you have one oxygen, so you can think of couple of functional group. First of all, it can be like hydroxyl, like alcohol group, and it can be also like carbonyl group, and also it can be like ether group. So since we already have in the IR already have a carbonyl group peak, so in that case the you can cross out alcohol and you can cross out ether, because one oxygen and that is a carbonyl group clearly IR is showing clearly there is a carbonyl group. So from the molecular formula, one oxygen is used by the carbonyl group, and that is also matching with this soda number. If you see the soda number 1 and carbonyl group has a double bond, so soda number 1 is covered up. Now if you have the carbonyl group and one oxygen, so as I said in my previous video, that if you have one oxygen, you cannot imagine carboxylic acid or ester. So there is no way to have the carboxylic acid or ester, because those require 2 oxygen. Here you have only 1 oxygen. So if you have the if that 1 oxygen is not like ether or not like alcohol, so and also you have the carbonyl peak, so definitely you can see that carbonyl peak either ketone or aldehyde. Now how you will confirm it is ketone or aldehyde? So 2b aldehyde, like as long as you have the carbonyl group, so along with that, if you have something like very like sharp, like distinctive peak around 2700 and 2800, mentioning two special peak with the carbonyl peak, then you can say, okay, this is the aldehyde. But you don't have those kind of peak around 2700 and 2800. Okay, so in that case, you can cancel your aldehyde thing. So it is not aldehyde. So this specific peak is for ketone. Okay, so now you got in your hand like ketone, like carbonyl group, and soda number is 1, that is done with this. Now let's go to carbon NMR. So in my last video, like part 4, I said in the proton coupled carbon NMR, if you see quartet, so this carbon is quartet, that means that has 3 hydrogen attached in it, because with the n+1 rule, 3 + 1 is 4, that means that carbon will give you a quartet. So it is a methyl group. And then there is another quartet, so that quartet is little bit upfilled, not like very close, so like this quartet, so there it should be like another methyl group. Okay, but it may be close to something, some group or something, that's why it is little bit up. And then the third one is a triplet. Okay, triplet means you have a methylene group. You have a methylene group. So in the proton decoupled, you are seeing only 3 carbon in the aliphatic region. That means those are sp2 hybridized. So first one, as we know, this is matching with this methyl, and this is another methyl, and this is like methylene group. But here in both cases you have carbonyl group, and as from the IR we already confirmed it is ketone. And also in my last video I mentioned, especially like part carbon NMR part, I mentioned if you have any peak above 200, that is definitely ketone. Okay, so you see that carbon already there. So now we have 4 carbon information. One is like methyl, very shielded. Another is like another methyl, little bit deshielded, like not exactly the first one. And one CH2 peak. Okay, now from the proton NMR, here you can see, if you see the like with the peak, if you see like this, that is integration. So that integration size normally show like the length, like how many proton is there. So if you consider from here to here that length, and also from here to here that length, they are almost same. That means, and we know like the first peak is a methyl group, so that is a methyl group, like 3 hydrogen is there. So ultimately this singlet, this is a triplet. Okay, and this is a singlet. The singlet also for 3 hydrogen. So that means there is another methyl which doesn't have any neighbor. And here you have like a little bit one less than this length, that means 2 proton. So that is for maybe CH2. Okay, so we already get that information from the carbon NMR. So in that case, now we need to put all those together. So first of all, let's put, like we have carbonyl group, one soda is gone from the IR and the carbon NMR and this proton NMR. No, in this proton NMR you will not get any information for ketone here, ketone group. Okay, now you have to put a methyl group, which since that methyl group is giving a triplet, that means which has a 2 hydrogen as a neighbor. So this methyl is seeing that hydrogen and that hydrogen 2. Then 2 plus 1, that means it is giving triplet 3. Okay. So 2 plus 1 is 3. Then it is giving you, oh, sorry. So and definitely this hydrogen also will see these 3 hydrogen as a neighbor, so that will give you a quartet, and that is a quartet around 2. Okay, now you might see like why that quartet is up, like above 2, because that carbonyl group, sorry, that CH2 group is directly attached to this carbonyl group. So any proton next to carbonyl group normally show up around 1.8 to 2.5 something. So that's why that is giving you a quartet. This hydrogen is getting splitted by the neighboring methyl proton. So that methyl proton is splitting this hydrogen as a quartet, but since it is directly connected to the carbonyl group, that's why it is up. Okay, so still we have one more CH3 like carbonyl group, and that is singlet. That means it doesn't have any neighbor. So that means you can put that CH3 group here. So if you now found the 3 bond away proton, you will not see any neighbor for this specific group. For this specific group, you will see like now count like 1, 2, 3, 4. So it is like 4 bond, but we are not considering 4 bond. So finally, we can say this is the structure. So now, if I want to write clearly, so and you can consider all the information here. So let's see how it will be the structure. So CH carbonyl group and CH. So now you can see the peak like this. This is 1 carbon, this is 2nd carbon, this is 3rd carbon, this is 4th carbon. So that 1 carbon has 3 hydrogen, that is methyl group, and that is shielded. So that is the very first one. Okay, and the second group has a 2 hydrogen, and that is like here, this one. And the third group doesn't have any proton, and fourth group has a proton but it has no neighbor, so that is the like 4th one. Okay, and in the carbon NMR you already know, like we get those information. So now in the carbon NMR we can clearly give the number with the structure. So this is the number 1 carbon, this is the number 1 carbon, and this is the number 3, not 3, this is number 4 carbon actually. So this is number 4 carbon single, but it has a 3 hydrogen atoms. That's why in proton coupled it is giving you quartet. And this is number 2 carbon, and this is number 3 carbon. So finally we can say this is the structure. So methyl group, CH2 group, carbonyl, and CH3 group. So this is the solution for this problem. So I hope you understand how we are determining the structure from the information given, like IR, mass, molecular formula, and also the like little bit information from UV, and mostly information from carbon and the hydrogen. So let's see, we can do some more examples. Let's see our second problem. Here in the IR, first of all, always look for the molecular formula. Okay, and this molecular formula has again carbon, hydrogen, and oxygen. So the number of carbon is 3 plus 1 minus hydrogen number is 6 over 2, and since you have oxygen you don't need to do anything else. So 4 minus 3, and you have soda number 1. Okay, so you must have a double bond. any type of double bond. Either it can be carbon-carbon double bond or it can be carbon-oxygen double bond. Okay, so let's see now in the IR what are the information we are saying. Clearly we can see one carbonyl peak here, 1715. So this is a carbonyl group. And now look, in this molecule there are two oxygen. Okay, two oxygen. So those two oxygen can be, as I mentioned in my IR lecture, if you have two oxygen, you either consider the carboxylic acid or the ester. So when it will be carboxylic acid and when it will be ester? First of all, you have to have a carbonyl group peak, and you have the carbonyl group peak. So this is the carbonyl group peak, like 1715. Now, to be carboxylic acid, you have to have a weird cow-udder shape band from 2500 to 3000. So you can clearly see that there is a band here from 2500 to 3000 to 2500, and it's like ugliest peak. So that is for actually the carboxylic acid OH band. Okay, so including, it is not alcohol, remember that is for OH from the carboxylic group. That means combinedly we can show you, you have the carboxylic group, so you should have a carbonyl peak and also a OH group attached. So that for that carboxylic acid, you will see a carbonyl peak around 1715. You got it. And for this OH connected to this carbonyl, you will see a ugliest shape around 2500 to 3000, and that is present there. So IR is kind of confirming that you have the carboxylic acid. Okay, now let's go to the carbon NMR. So in the carbon NMR, remember you have 3 carbon. Okay, so in the carbon NMR, there is one carbon and there is another carbon, 3. So that carbon is definitely for the carbonyl group, and you know that already we have the carboxylic acid. So that is done. So we have 2 more carbon. So that 2 carbon here, although I forgot to mention, there is another technique called DEPT. If you see here, that is called DEPT. So DEPT, there are a couple of different DEPT, but mostly here the DEPT is given like DEPT 135. That is called depth 135. In depth 135, any CH3 peak or CH peak always will show up, like up signal. Those are for CH3 or CH. Okay, any down peak, that is for only for the CH2 peak in the DEPT 135. So here that information is given. So from this there are 2 carbon, 1 and 2. So if you see here, one is showing up and 2 is showing down. Okay, so that is 2. So that means the first one is either the CH3 or CH2. Okay, and the second one, either the CH3 or CH, but the second one, it is confirmed that it is CH2. So you already have carboxylic acid group. Now you have CH2 group, definitely, because the DPT is showing that. And now number 1, whether it is CH or CH3. So definitely, if you count the hydrogen number from your molecular formula, so how many already you got 2 carbon, like one is CH2 and another is like COOH. So how many proton is gone? Like 3, and here is 1, 4. 2 and 1, 3. And how many hydrogen you has? 6. So from the 6, 3 is gone. So another 3 hydrogen remaining, and you have 1 carbon remaining. So definitely it is confirming that this carbon might be a methyl group. Okay. So from here we have another group, methyl. So now if I see on the proton NMR, then you will see a triplet. Okay, triplet. And if you see here the integration value and here the integration value, so clearly you can say if it is 3, then it will be 2, the ratio, like little bit less, right? So definitely that means there are two hydrogen and it is quartet. Quartet means it has a neighbor 3 proton. Okay, that means it is a CH2 peak in the proton NMR, and this is triplet for 3 proton. That means it is a methyl peak which has a it is a methyl peak which has a two neighbor. Two neighbor means this one. Okay, so now it is kind of confirmed, and here at around 11 you see a peak that is also says exchanges with deuterium oxide. So carboxylic acid proton always can be exchanged with the deuterium oxide. Like if you add water, that water can be exchanged, like that proton that carboxylic group can be like COOD. In that case, sometimes you may lose that signal in your NMR. That's why it is said exchange. So now, from all those informations, what we are getting from these carbon NMR and proton NMR, clearly now you have the information in your hand. Let's put all those information together, pieces together, and then we can get the molecular structure. So first of all, we have a methyl group, definitely that also has a neighbor methylene group CH11. So if you count 1 2 3 and 1 2 3 and also 1 2 3 1 2 3, so all those methyl has a two neighbor, so that's why it will give you a triplet in the proton. Okay, in the proton, and that CH2 peak also has three neighbors, so it will give you a quartet. And in the structure we have only 3 carbon, and we already know we have one carbon with like carbonyl group also has a hydroxyl group. So now you are seeing the triplet, quartet, and the carboxylic group, and this is the final structure. So in simpler way, we can also draw that structure like this. Sorry. Or maybe this way. CH3, CH2. Why? CH3, CH2, COOH. So this is the final structure. So I hope you understand the assignment of these peaks. If you have a question, you can ask me. Now I'll go slowly, little more difficult problem, and slowly we will build up the knowledge of structure elucidation slowly. If you have any question, then please ask me in the comment, and if you like it, give like and click bell button to get more information or update on my channel, and hopefully it will help you to build up the structure elucidation from spectroscopic data. Okay, so in my next video I will bring more new complex structure, and hopefully till then stay fine, safe, and thank you for watching my video. Bye now.